Welcome to a special episode of our podcast, where we highlight the importance of remote sensing and the science behind understanding it. Today, we are joined by one of SSAI's group managers, Sudipta Sarkar from NASA Goddard Space Flight Center, an expert in satellite data systems like MODAPS and VIIRS LandSIPS. We will explore how information collected from space helps track changes on Earth and support better decision making. As Sudipta says, every pixel of satellite data is a clue about our planet. We just need to know how to read it. Let's get started.
First question I wanted to ask you was, could you please tell the audience about yourself and describe some of the projects you have worked on at SSAI?
Sure. And again, once again, thank you, Jason, for this invitation. I'll try to be brief. I think, the way I look at myself, I am more of a, what you can call as an earth system science and a remote sensing science professional. That's been primarily my expertise. And obviously, my time at SSAI has been largely dealt with, managing and running a large science data system. I come primarily from a geoscience background, so I have a master's in applied geoscience. I have another master's, in focusing on really earth system science and remote sensing, and I also have a PhD in the latter. And now, if you ask me, my entire life has really been, my working life has really revolved around remote sensing and how you can make the best use of remote sensing from application side as well as from a science, perspective. So, like for example, I have dealt, with coming up with, decision support, building decision support systems around remote sensing data products, remote sensing tools. I've also built solutions, based on remote sensing data products that focuses on, tackling land cover change, HBU potential. And for if your users who may not know what HBU stands for, it stands for like higher and better use. So how you can basically make optimal use of land, for serving a community. And then for looking at forest age, for example, for large paper companies, or for like commodity monitoring. That's a big thing right now nowadays, for especially for hedge funds and for large food companies like the likes of Cargill or Bunge or, or Louis Dreyfus, who are actively involved in gathering crop intelligence. So I've been involved in that side of the things, and have also looked at, the remote sensing and how you can leverage remote sensing data products, for earth system science studies, environmental monitoring, land atmosphere interaction. So that has been one of my TED topic really, to basically, to see people talk about its impact on land, but how does it work the other way? Like, whatever land changes that you are seeing, land cover changes, right? So I have been kind of looking into that also, in the past, not right now, because right now I'm too much involved in the operational aspect. But in SSAI, obviously, I have been mainly involved, in managing, this data systems, the MODAPS and LandSIPS, which I think, we can probably discuss later on. And my role over there has kind of evolved over time. So I joined mainly, as a science developer and a QA, someone, who was responsible for maintaining the QA. And I have really helped, in that capacity, define, updating algorithms, fine-tuning algorithms, or even coming up with science algorithms. Oftentimes, even maintaining some science algorithms that are no longer maintained by particular science teams. And then I have gone on to also lead the QA team of MODAPS and LandSIPS, which, by the way, is also known as LDOP, standing for Land Data Operational Product Evaluation. And then of late, in the last 5 years, I have been managing the entire MODAPS LandSIPS, which, by the way, is a large science data system that's churning out like, terabytes to petabytes of data every day and every year. So I have been kind of like an operations manager managing that, the MODAPS and LandSIPS. And then only recently, I have kind of also taken on a more managerial role, basically looking at the overall Port 619, where these MODAPS and LandSIPS are housed at NASA Goddard Space Flight Center. I've been managing the Terrestrial Information System labs in that course 619, and looking at overseeing the entire gamut of operations in that lab. So yeah, that's kind of in a nutshell what I had been doing lately, and my work has been around.
Sudipta, I really appreciate you highlighting all of your background and your experiences that you've had at SSAI. You've definitely done quite a bit since your time here, and it's super, super cool in terms of the many different projects that you are currently involved with. And Sudipta, I wanted to transition on to my next question, which was, as someone who leads critical systems, ensuring the quality of satellite-derived Earth science data, how do you see the intersection of computational science and research about our planet Earth evolving? And what excites you the most about the future of remote sensing and understanding our planet?
That's a great question, Jason. I mean, it's how do I even start to answer that? It's really exciting time. It's really exciting time, I feel, for Earth system science professionals and remote sensing professionals. And in fact, that's what I actually tell whoever is interested in this kind of profession. And why I say that is because and the way I think of it, is because there are 4 areas, or there's convergences happening in 4 different areas that makes it all the more exciting. And so number 1 is obviously, your innovations and advances in the field of hardware. So for example, right now you have very powerful computing systems coming in with very powerful, CPUs, memories, all that. And then right now, of course, there's advances being made in quantum computing, right? God knows where that will, lead us to, right? That's some wonderful possibilities out there. So that's one thing. Second thing is, in terms of storage, right? When the entire, even 20 years back, you had very limited amount of storage, the storage was a huge issue, and you could only produce a few data sets and few data products. So storage has vastly improved. Now you have cloud-based storage. And you have even the hardware and storage cost is also coming down. So you can really think about producing and archiving vast amount of data that was unheard of, or that was unthinkable, even a few years back. So that's hardware and then the storage. Then the third thing is advances being made in the field of remote sensing itself, if you can see. Like the sheer number of, the proposed missions, satellite data missions, that are already, up in the air, or that are in the planning stage, or that may come up in the next, couple of years. And that's not only for NASA. It's if you talk about all the other countries like JAXA, the Indian Space Research Organization, ISRO, the ESA, all the countries. So, and you talk about now you have these geostationary satellites as well as polar orbiters. So with geostationary satellites, you can really focus on a particular area of your choice and keep monitoring that area day and night across the year. Whereas in polar orbiters, you have, you can basically have the luxury of, looking at different areas, every few days, and and building up a consistent record. Then you have missions that are targeting different aspects of electromagnetic spectrum, like from microwave, active and passive, to ultraspectral, hyperspectral, moderate resolution, multispectral, different parts of the electromagnetic spectrum, depending on what problem you are trying to solve. So that's another thing. And then you have very finest resolution, like going down to even centimeter and millimeter scale, to even very coarse resolution, observational capabilities. So if you put all that together, that's a sheer number and just huge amount of data and information that's coming at you. And so that's the third thing. And then the fourth thing is, of course, the advances made in the field of computational techniques. I think that will be a really game changer. And I'm talking about probably this machine learning and AI. Now, of course, machine learning has always been there. Even I have grown up learning about machine learning, as part of remote sensing and all. But more and more advances are now being made in machine learning. Now, so what's happening as a result is, okay, because of hardware and because of storage, improvement in storage capacities and advances in remote sensing missions, you have a lot more missions, you have a lot more computing capabilities, you're producing vast amount of data, But then at the end of the day, one has to think, what are we doing with all that data, right? Because data is, after all, just data. But there has to be a technique to really extract meaningful information out of that data so that people can, end users can really make use of that data or that information in their meaningful way, in whatever problem they are trying to solve. And I think that's where the machine learning and all comes into play, right? Because you can think of, this is like a 3D volume of data, right? X and Y, and then you have a time axis, right? And then you have this, even a 4D, and then you have multiple data sets, right? Sometimes even redundant data sets coming in. What do people do with that? It's just a sheer volume. It's just overwhelming. But now if you throw in machine learning over there, you can actually now build very specific queries, very specific decision support systems, your whatever you want, build advanced metrics on top of that, and only fetch that required information, for example, in Amazon cloud storage. So what you are eventually storing in your system is very nominal information, whatever critically you need out of that sheer volume of data. I think that's very exciting. And all this is really advancing, right? Even as we are speaking, advances are being made. So it's very exciting time, Jason. And I think, again, sky is the limit. In terms of where we end up, in terms of, remote sensing and what advances we made in terms of monitoring this planet, it's exciting time. And I think it's also more exciting, because we have to, let's not forget that, Earth is our mother Earth, it's our planet that we survive, right? So I hope someday that all these capabilities, will lead us to in a position to better monitor this planet and make some positive changes. So yeah, exciting time. And again, thank you for asking that question.
Absolutely, Sudipta. Well, and I can definitely tell by your enthusiasm and your excitement that this is definitely a very exciting time. And I couldn't agree with you more. And you brought up a lot of great, excellent points in terms of all the advancements that we have had, over the last several decades or so. So, Sudipta, I really appreciate you answering that question. Sudipta, I wanted to transition on to my next question that I wanted to ask you. You mentioned a little bit about forests and your work with forests, and forests are critical to both environmental health and also national security. How does your work in satellite data systems like MODAPS and VIIRS LandSIPS help us monitor forests, land use, and our changing planet? And for those of our audience and viewers who might not be as familiar, can you briefly explain to them what a satellite data system or a science data system is based on your role?
Okay. Again, wonderful question, Jason. I think, you're trying to address a lot of topics. So let me start by briefly describing for your audience what a data system is, right? So, on MODAPS and LandSIPS, so a data system, as the name suggests, it's basically a science data processing facility where you are churning out, again, terabytes to petabytes of data. Now, all these missions that we just talked about, you have all these remote sensing missions, and instruments that are continuously orbiting the Earth, and sending in all these, signals, right? Now, how do you get any meaningful information out of those signals, right? So they have a dedicated team of scientists who are coming up with all these meaningful algorithms to take this, this stream of electrical signal that are being, continuously streamed onto all these ground receiving stations. And they are trying to translate that into these meaningful parameters and products, that in the end users can make use of. And that's where the science data system comes in, right? So data system basically works with the different scientists, takes their algorithms, onboards their algorithms, and runs their algorithms in a centralized facility and they package the algorithms such that all the algorithms can be run consistently, and ensuring reliability, ensuring scalability, and with consistent calibration thrown in so that all the instrument measurements are compatible with each other. So all that being factored in, and then the science data system manages all that and then helps produce consistent data sets for every satellite mission that's out there. And so specifically in case of MODAPS and LandSIPS, it's basically two sides of the same coin because it's the same team who's involved. MODAP started early off, it's a bigger brother. It started way back in the early 1990s, early to like mid to late, I think I would say late 1990s with the commencement of the NASA EOS mission, the Earth Observation System mission, which was really a flagship mission that's kind of still continuing. And we produce data from MODIS, Terra, and Aqua. These are the two Terra and Aqua, the two flagship missions of the EOS. And we largely deal with the MODIS sensor, which is a moderate resolution sensor from that. And that is the MODAPS component. So it is basically the MODIS adaptive processing system, where we basically produce all the land and atmosphere data products from the MODIS, Terra, and Aqua. And then you also have the similar data system for producing the land data products of the VIIRS instrument that is on board the SNPP and the current suite of JPSS missions, starting with NOAA 20 and the NOAA 21, and then soon to be launched the NOAA 23, that is the J4. And so in essence, we are a bunch of people, who are ensuring that consistent data products are being generated spanning multiple land and atmosphere parameters and covering over the last 25 years and ongoing. And so that's what the data system is. Now let's take on your other question about how does that help, in monitoring, global, this, plant cover and all. So as I said before, if you look at, for example, MODAPS and LandSIPS, and there are other SIPs out there, like, you have the ocean SIPs and other SIPs, atmosphere SIPs for VIIRS and all that. Now, just for MODAPS and LandSIPS, so you have these 25 years of data products that are coming out from MODIS, Terra, and Aqua, and then ongoing from the VIIRS mission, starting from 2012 and onwards. So you have this consistently calibrated data record that is covering every part of Earth, every 16 days. So every 16 days, you can basically ensure repeatability over a particular area of your interest. Now, if you are a scientist, right, and if you are trying to observe or track a particular phenomena, say in this case the plant cover, or the changes in land cover, changes in plant, whatever, forest cover, vegetation, whatever. What more you want rather than other than a consistent record observation over time, over the last 25 years. So that really gives you the ultimate tool for monitoring any change detection. And then on top of that, you have these very targeted products that will help you get the job done. So I'm talking about measurement of Earth's greenness, measurement of trees' canopy density, measurement of percentage tree cover, measurement of carbon fixation, how much carbon is the canopy being able to fix. This has huge implications for global energy balance. And then this energy balance in turn can drive the entire, the atmosphere circulation, the large scale circulations you are seeing, both atmosphere and oceanic circulations. This energy balance has huge impact on those. So you have consistent data records that are, targeting different aspects of the global forest cover in terms of canopy cover, in terms of carbon fixation. So all that, and the percentage tree cover. So as a planner or, as a modeler, this is a great opportunity for you. Not only that, so you can also throw in this data to your models to better constrain your models, to improve your model parameterizations, right, as model boundary conditions. So your models will also give better predictions about changing forest cover, changing global, land cover, all that. All in all, it's a great set of tools and a great set of, great opportunity. Not only that, there's also two aspects to that. You have a near real-time opportunity where you have data coming in within 3 hours of data acquisition, and then this meaningful data being distributed to end users within 3 hours. So now you think about what you can do with that. You can basically monitor all this, developing, storms, developing catastrophes and all that stuff, for which you need very quick, rapid data coming in. And then you have more consistent, data record that comes in a little later that is very meaningful for all these data studies. And as you mentioned, in case of any consistent forest cover and change studies. So now, with respect to how SSAI fits in and what SSAI has been doing, it is all about the team SSAI, and as I said, it's team SSAI have been really instrumental, if you take it from calibration to, data production, data archiving, data QA, in some cases, even the algorithm development and maintenance. It's all about team SSAI. So I think, I don't know, it's a great job, and I'm proud of the team that, I work with, and also the other teams, I collaborate with routinely. And I think we have been doing a wonderful job in giving the world community a consistent set of data records that are very vital for not only plant cover, but for any kind of assessment studies. You cannot talk about any kind of studies without referring to MODAPS and VIIRS and any other instruments that, coming out of our shops. It's a vital set of tools, yeah.
Absolutely, Sudipta. Well, first of all, I really appreciate you breaking down for our audience and viewers in terms of what a satellite data system or a science data system is. I've heard of it a little bit, but I've actually learned some new tips and information in relation to what those items are. So I definitely appreciate you breaking that down. In addition to that, I really appreciate you sharing more about MODAPS and VIIRS LandSIPS, and how your work helps to monitor forest land use and our changing planet. So Sudipta, again, I really appreciate you highlighting your work in satellite data systems and explaining how SSAI is making that impact. Sudipta, my final question I wanted to ask you was, and this is a fun question, just as a side note, but the question is, let's say MODAPS and VIIRS had personalities. What kind of coworkers would they be in the SSAI office, just out of curiosity?
I think, and again, this is my personal take on it. So I feel like, MODAPS, you think about, two sets of friends. So MODAPS is like that old guard, that friends who has been around for a long time, who has been, who intimately, his capabilities, and, who has often come to you, helping you out in dire needs. It's the trusted old friend, that you can always count on, who has always been round the corner. Whenever you have needed something, that friend has been out there. Now, again, sad to say that MODAPS is in a sunsetting phase right now. But if you think about it, it's been there for 25 plus years, serving the communities, global community. So I cannot think of a better example than a very trustworthy, time and tested friend who has been out there. And then VIIRS is like that new kid on the block who is just come in, who is, getting to know others, and others are also getting familiar with VIIRS and what this new kid is about, what he or she can offer, right? Is a new kid on the block. So, and again, great promise for VIIRS, and I think, and it's expected to basically, carry that torch forward from MODAPS, right? So MODAPS has carried it up till this far, and then VIIRS is the forerunner, the next one. So it's a new kid on the block. So it's a great promise. One is that forefather, who has reliably served that generation, who has reliably served up to a point, at the trusted old friend, who you're a little bit sad to see go eventually, because the time for it is coming. But hey, ain't that true for every one of us, right? Every one of us, we have some limited time, so we have to eventually say goodbye to every one of us. But that's how I feel, MODAPS is the tried and tested friend, and VIIRS is the new kid on the block who's coming in with great promise. So we are hopeful for VIIRS, and, we are thankful to MODAPS for serving us so much all this while. Yeah, I think that's the way I would like to feel. And again, I'm happy to be associated with both of them for so long. And I think it's a great set of tools for the global community. These two have been really instrumental and valuable.
Absolutely, Sudipta. Well, I appreciate you explaining a little bit of an analogy in regards to MODAPS and VIIRS in terms of their personalities. I can definitely tell that you are super excited. All of us at SSAI are very excited about these new opportunities, and all of our audience and viewers should be excited as well in relation to hearing about these cool opportunities. Sudipta, with that, again, I just wanted to thank you again so much for taking time out of your very busy schedule to talk with me today about your work and projects at SSAI. You are truly a rock star who is really making an impact and a difference globally. And everybody around the world is going to continue to be fascinated by the great work that you and your team are currently doing. Please definitely keep us informed in terms of some additional insights that come, especially with VIIRS coming up. And we look forward to some continued insights and data, and we cannot wait to highlight it.
Hey, thank you, Jason. I think this is a great opportunity for me to really, highlight some of the work that we as a group have been doing for the last several years. And I think it means a lot for our group also. So thank you again for giving me this opportunity and to be a mouthpiece for the entire group, not only for myself. So I really appreciate this opportunity. And again, exciting times for the entire community. So I couldn't be more excited. So thank you once again. Appreciate that.